Now I will explain how a decision making process in an oil company for oil exploration can be enhanced using probabilistic math modeling. So the decision making process can be made more efficient and more reliable while the exploration phase of oil reservoirs. So what is the exploration phase? So basically, before a particular site is drilled, for probable site is drilled, there are many different kinds of surveys taken, and based on that, the decision is taken that whether or not to proceed with the particular site or not. So, uh, classic AI can be of great use in this thing, make our process more efficient and better. So, we can use decision to help us in this regard. So, this is how we will can capture the effect of exploratory actions in our decision tree model. So, um, the information obtained through exploratory actions, like basically different kinds of surveys, can affect our probabilities of later outcomes. So, basically, what it means is that we carry out a particular method or a particular survey which gives us more information about the project, and we use it in our probabilistic analysis and the probabilistic modeling, which would help us in further taking the decision whether or not to proceed with that particular site or not. Now, the probabilities on the later outcomes can also be conditioned on the past observed outcomes and the past actions as well. Now, all of such events are remembered, and each of them are considered to take the decision. So, this is like a graph problem where each and every uh, s- a, basically a decision tree problem where each and every value will be recalculated and is dynamic. So I would like to present an oil wildcatter problem. So basically this is a very toned down and a basic version of the oil determination program exploration phase, which we will then make it more complex and more realistic after explanation of this very simple problem. So, an oiled wildcatter has to make the decision whether or not to drill a specific site. And from the existing geological knowledge, we are able to determine that the chance of hitting an oil deposit is 40%. So the probability that the oil is present, that it is true, is 0.4, and probability that there is no oil, such that probability of oil is false, is equal to 0.6. Now, we would also like to associate the costs as well, because the cost cutting and the driving of profits is a very important issue for the oil companies. So, we need to incorporate the costs of drilling and the possible payoffs as well if we are able to find out the oil. So the possible payoff if we are able to find out oil is 220,000, and if no oil is found, the value is 0 since we did not find anything. So this is the our source node, and we start we have some particular two options. The first one being drilling and second being no drilling. So if we do not drill, we are certain that we won't be able to find anything and our payoff will remain 0. So the probability of payoff 0 will be 1 and the payoff will be 0. Now in case we opt to drill, then this is the node where we will reach, and there are two paths. The first will be we probably might find oil in this case, and we probably might not find oil in this case. So each of them have probability zero point 0.4 and zero point 0.6. Now, since the drilling cost is 70,000, the outcome, fine net outcome, will be 220,000 minus 70,000, because this is the revenue and this is the expenditure, so 150,000. And 70,000 will be the loss if we do not find anything. So the value of this node can be calculated using the expected value of this branch and this branch. So 150 multiplied by zero point 0.4 plus zero point 0.6 into minus 70 gives us an expected value of $18,000.
Hello everyone, I am Saurabh Kumar. Now we are going to discuss this seismic oil wildcatter problem by assuming that in addition to the drill or no drill choices, we have an option to run the seismic resonance test. Now what do we get in the seismic resonance test are some results. The first one is closed pattern, which states that it is more likely that oil will be present in the reservoir, whereas the other one is diffuse pattern, which gives us the likelihood that oil is not present in the reservoir or the oil is empty. So, in this way, our task is to find out the probability of presence of oil given a particular test of seismic resonance. So, from this chart, we can see the presence of oil and the test pattern has some relationship for the probability. The probability that the test is closed given oil is not is present is 0.8, whereas probability that test is diffused given that oil is present is 0.2. Probability that the test is closed given that oil is not present is 0.3, and the probability that the test is diffused given oil is not present is 0.7. So from here we have to find out the probability of the presence of oil given a particular test. Now we know here we are given test cost equals to 10,000. So what we are going to find out is this value of 0.64. How do we get it? This 0.64 value, which we get in the rightmost branch of the topmost tree node, this we get from Bayes theorem, which gives us the probability of the presence of oil given that test is closed. This will be equal to the probability that test is closed given oil is not present, which is equal to 0.8 into probability that oil is present, which is equal to 0.4. So 0.4 into 0.8 will be 0.32 divided by probability that the test is closed, which is 0.5. So 0.32 divided by 0.5 is 0.64. So this is the probability that oil is present given the test is closed. Similarly, for the test results to be diffused, we get 0.36 as the probability value. So now, from these two probabilistic values, we find out the estimated cost, which will be, or revenue, which we will be getting if we explore the oil or not. So if we explore the oil, if we drill, then the estimated amount will be 0.64 into 140 minus 0.36 into 80. This is the same as the probability that oil is present given that our test result is closed, which is the branch for this estimation. This is 0.64 into 140 and its difference with the probability that the oil is not present given the test is closed multiplied by 80. In this way we get total revenue of 60.8k. So from these two values, from drilling estimated value we get 60.8. If we do not drill, the estimated cost will be minus 10k. That is, we have the estimated revenue will be minus 10k. So we would be having some extra charges of 10,000, which will be a loss for us. So the estimated amount or estimated cost or estimated revenue if we are doing the test will be 60.8 multiplied by zero point 0.5 minus 10 into multiplied by zero point 0.5. That will give us 25.4k. So the estimated revenue is 25.4k if we do this test. Whereas if deriving it similarly, if we do not do the test, then the estimated revenue will be 18k. So this can be simply observed that testing is way more better as the overall revenue generated is much higher. Here in this case our uh, cost is much lesser, but in actual oil and gas industry the overall cost is too high, and this will be affecting our overall revenue by a huge extent. So from this estimation, we can see that testing is definitely better. So we'll be choosing this path of test, and from this testing path, if our if our testing result is closed, then we'll be drilling, and if the testing pattern is diffuse, then we'll not be drilling the reservoir. So these are the two best paths based on our result. Now the closed and diffused are equally probabilistic, so that is not in the control that is not under our control. But using this, we can find out these values. Now, what do we get from this? Does this test make sense? Yes, it does. As the decision maker has to keep this in mind, whether he has to drill the reservoir or not. And this decision tree works out pretty well, as the expected value with the test was 25.4k, which was the estimated revenue, and the estimated revenue without the test was 18k. So net difference was 7.4k. If we see 7.4k percentage wise, then it is approximately 30% of the overall revenue generated. So this loss is prevented. If we assume that oil industry works in $1 million, then you can probably assume that this game tree will definitely uh, affect the overall profit or loss of industry by huge margin. So thank you very much.
Hello everyone, my name is Rohit Kumar and I am final student of the course Exploration Geophysics. So my topic is how we use knowledge graph for learning geological data. So as we know, oil and gas industries are very much dependent on geophysical interpretations and geological data. So in this PPT, I will show how geological data are learned from knowledge graph. So knowledge graph is very popular segmenting network that has been widely used. So it basically uses NLP and data mining algorithms uh, for defining for giving any knowledge on any data. So let's move to the next slide. So okay. So basically, if we see how knowledge graph is formed in geological data, so first framework is knowledge extraction. Basically, it is divided in two parts: knowledge extraction and knowledge management. So, in knowledge extraction, we have four branches. So, first one is analyzing the available data sources. So, this includes uh, learning text, but we know that only using text we can't say anything because text doesn't say any meaningful data. So we uh, we need some sentences. So for that we need internet, and so second point is internet encyclopedia. So we basically search the keywords in internet to get some data. So basically geological data are have geological data have two parts. First is the practical field data which we get from fieldwork, and second one is the internet data. So again, so the third point is entity extraction. This includes text processing using any internet sites where we basically uh, segments the word and just extract the keywords from there. So entity extraction have three parts. You can say four parts. First is word segmentation, frequency statistics, and web crawler and keyword extraction. So the fourth is relation extraction. This is basically after finding the keywords, we relate two, three types of documents of same of any particular keyword, and we try to relate all the four documents or five documents on the basis of particular keyword to get more accuracy in our data or stuff like that. So as I said, structure has two parts: one knowledge management and knowledge extraction. So after coming to knowledge management, it is basically of two part: knowledge graph retrieval and backstage management system of KG. Uh, you can see in this image, uh, I have shown graphically how data is geological data is processed using knowledge graph. So we have the geological data which we have got from field, and after getting the data, we try to relate from this internet data. And I have just you can see knowledge extraction and knowledge management, and I have explained this. If we dive deep in knowledge extraction, then it contains many subparts. We can see in this image. So we know that we have two data. One is geological field data, which we have finded in our field trips, and second one is internet data. So we just uh, we use web crawlers and from comparing both geological field data and geological internet data, we try to get some uh, entity from there. So entity extraction again contains, so it contains word segmentation, frequency statistics, and uh, while doing word segmentation, we try to filter out the stop words because it is not necessary. So we just keep the keywords, and again after going through this, we have two options. One is uh, the data which is extracted can be of geological domain, and second one is the encyclopedia labels which we have used for finding the keyword things. So after finding these two, we merge both the datas and finally get the geological entities, which again contains all the extracted data from internet and related with geological domain data which we have. So after this, we try to uh, do some relation extraction uh, between both encyclopedia data and geological field data, and uh, we try to figure out the relation between these two. And you can see this image says that these are the geological data which we have, and these are after putting this input in all the stratigraphical data, we can relate every features with every particular feature with all the features. So this is this is quite useful and it is used in geological domain. We know that geophysical interpretation is quite important, but many times geophysical data are not uh, enough to give any important relation of oil and gas wells. So basically, we need geological data for finding a priori information. Using a priori information, we can uh, make ill post data to uh, uh, something good to find oil and gas. So this process is quite important for finding oil wells and gas. Thank you.
Hello everyone, my name is Chirag Singhal and today I'm going to discuss about hybrid heuristic search as an inversion algorithm. So the heuristic search searches the solution by a method of trial and error. In this, success of each attempted solution is assessed and used to improve the subsequent attempts. This is done until a solution acceptable within defined limits is reached. In geophysics, the seismic data of an area are used to make a model of the layers below the crust. Heuristic search can be used to reconstruct the 2D soil profiles using surface PSV waves obtained from the conventional seismic reflection survey. The algorithm will minimize the misfit between the observed waveforms and the synthetic waveforms that are computed from numerically generated soils and create the optimal soil model that fits the observed waveforms. This will lead to a progressive reduction of the difference until it reaches the minimum fitting at the end of the inversion. Thank you.